Preface and introduction to A Popular History of Astronomy during the 19th Century. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Melanie T. A Popular History of Astronomy during the 19th Century by Agnes Mary Clerke. Preface and Introduction. Preface to the 4th edition. Since the 3rd edition of the present work issued from the press, the 19th century has run its course and finished its record. A new era has dawned, not by chronological prescription alone, but to the vital sense of humanity. Novel thoughts are rife, fresh impulses stir the nations. The soughing of the wind progresses, strikes every ear. The old order changeth more and more swiftly as mental activity becomes intensified. Already many of the scientific doctrines implicitly accepted 15 years ago begin to wear a superannuated aspect. Dalton's atoms are in the process of disintegration. Kirchhoff's theorem visibly needs to be modified. Clerk-Maxwell's medium no longer figures as an indispensable factotum. Absolute zero is known to be situated on an asymptote to the curve of cold. Ideas, in short, have all at once become plastic, and none more completely so than those relating to astronomy. The physics of the heavenly bodies, indeed, finds its best opportunities in unlooked-for disclosures, for it deals with the transcendental conditions, and what is strange to terrestrial experience may serve admirably to expound what is normal in the skies. In celestial science especially, facts that appear subversive are often the most illuminative, and the prospect of its advance widens and brightens with each divagation enforced or permitted from the straight paths of rigid theory. This readiness for innovation has undoubtedly its dangers and drawbacks. To the historian, above all, it presents frequent occasions of embarrassment. The writing of history is a strongly selective operation, the outcome being valuable just in so far as the choice what to reject and what to include has been judicious, and the task is no light one of discriminating between barren speculations and ideas pregnant with coming truth. To the possession of such prescience of the future as would be needed to do this effectually I can lay no claim, but diligence and sobriety of thought are ordinarily within reach, and these I shall have exercised to good purpose if I have succeeded in rendering the 4th edition of A Popular History of Astronomy during the 19th Century not wholly unworthy of its place in the scientific literature of the 20th century. My thanks are due to Sir David Gill for the use of his photograph of the great comet of 1901, which I have added to my list of illustrations, and to the Council of the Royal Astronomical Society for the loan of glass positives needed for the reproduction of those included in the 3rd edition. London, July 1902. Preface to the 1st edition. The progress of astronomy during the last 100 years has been rapid and extraordinary. In its distinctive features, moreover, the nature of that progress has been such as to lend itself with facility to untechnical treatment. To this circumstance the present volume owes its origin. It embodies an attempt to enable the ordinary reader to follow, with intelligent interest, the course of modern astronomical inquiries, and to realise, so far as it can at present be realised, the full effect of the comprehensive change in the whole aspect, purposes, and methods of celestial science introduced by the momentous discovery of spectrum analysis. Since Professor Grant's invaluable work on the history of physical astronomy was published, a third of a century has elapsed. During the interval, a so-called new astronomy has grown up by the side of the old. One effect of its advent has been to render the science of the heavenly bodies more popular, both in its needs and in its nature, than formerly. More popular in its needs, since its progress now primarily depends upon the interest in and consequent efforts towards its advancement of the general public. More popular in its nature, because of the kind of knowledge it now chiefly tends to accumulate is more easily intelligible, less remote from the ordinary experience, than that evolved by the aid of calculus from materials collected by the use of the transit instrument and chronograph. It has thus become practicable to describe, in simple language, the most essential parts of recent astronomical discoveries, and, being practicable, it could not be otherwise than desirable to do so. The service to astronomy itself would not be inconsiderable of enlisting wider sympathies on its behalf, while to help one single mind towards a fuller understanding of the manifold of works which have in all ages irresistibly spoken to man of the glory of God, might well be an object of no ignoble ambition. The present volume does not profess to be a complete or exhaustive history of astronomy during the period covered by it. Its design is to present a view of the progress of celestial science, on its most characteristic side, since the time of Herschel. Abstruse mathematical theories, unless in some of their more striking results, are excluded from consideration. These, during the 18th century, constituted the sum and substance of astronomy, and their fundamental importance can never be diminished, and should never be ignored. But as the outcome of the enormous development given to the powers of the telescope in recent times, together with the swift advance of the physical science, and the inclusion by means of the spectroscope of the heavenly bodies within the domain of its inquiries, much knowledge has been acquired regarding the nature and condition of those bodies, forming, it might be said, a science apart, and disembarrassed from immediate dependence upon intricate and, except the initiated, unintelligible formulae. This kind of knowledge forms the main subject of the book now offered to the public. There are many reasons for preferring a history to a formal treatise on astronomy. In a treatise, what we know is set forth. A history tells us, in addition, how we came to know it. It thus places facts before us in the natural order of their ascertainment, and narrates instead of enumerating. The story to be told leaves the marvels of imagination far behind, and requires no embellishment from literary art or high-flown phrases. Its best ornament is unvarnished truthfulness, and this at least may confidently be claimed to be bestowed upon it in the ensuing pages. In them unity of treatment is sought to be combined with a due regard to chronological sequence, by grouping in separate chapters the various events relating to several departments of descriptive astronomy. The whole thing is divided into two parts, the line between which is roughly drawn at the middle of the present century. Herschel's inquiries into the construction of the heavens strike the keynote for the first part. The discoveries of sunspot and magnetic periodicity and of the spectrum analysis determine the character of the second. Where the nature of the subject required it, however, this arrangement has been disregarded. Clearness and consistency should obviously take precedence of method. Thus, in treating of the telescopic scrutiny of the various planets, the whole of the related facts have been collected into an uninterrupted narrative. A division elsewhere, natural and helpful, would have been purely artificial, and therefore confusing. The interests of students have been consulted by a full and authentic system of references to the sources of the information relied upon. Materials have been derived, as a rule with very few exceptions, from the original authorities. The system adopted has been to take as little as possible as second hand. Much pains have been taken to trace the origin of ideas, often obscurely enunciated long before they came to resound through the scientific world, and to give each individual discoverer, strictly and impartially, his due. Prominence has also been assigned to the biographical element, as underlying and determining the whole course of human endeavour. The advance of knowledge may be called a vital process. The lives of men are absorbed into and assimilated by it. Inquiries into the kind and mode of the surrender in each separate case must always possess a strong interest, whether for study or for example. The acknowledgments of the writer are due to Professor Edward S. Holden, Director of the Washburn Observatory, Wisconsin, and to Dr. Copeland, Chief Astronomer of Lord Crawford's Observatory at Dunlick, for many valuable communications. London, September 1885. Introduction. We can distinguish three kinds of astronomy, each with a different origin and history, but all mutually dependent and composing in their fundamental unity one science. First, in order of time, came the art of observing the returns, and measuring the places, of the heavenly bodies. This was the sole astronomy of the Chinese and Chaldeans. But to the vigorous Greek mind added a highly complex geometrical plan of their movements, for which Copernicus substituted a more harmonious system, without as yet any idea of a compelling cause. The planets revolved in circles because it was their nature to do so, just as laudanum sets to sleep because it possesses a virtuous dormitiva. The first and oldest branch is known as observational or practical astronomy. Its business is to note facts as accurately as possible, and is essentially unconcerned with schemes for connecting those facts in a manner satisfactory to the reason. The second kind of astronomy was founded by Newton. Its nature is best indicated by the term gravitational, but it is also called theoretical astronomy. It is based on the idea of cause, and the whole of its elaborate structure is reared according to the dictates of a single law, simple in itself, but with the tangled web of whose consequences can be unravelled only by the subtle agency of an elaborate calculus. The third and last division of celestial science may properly be termed physical and descriptive astronomy. It seeks to know what the heavenly bodies are in themselves, leaving the how and the wherefore of their movements to be otherwise answered. Now, such inquiries became possible only through the invention of the telescope, so that Galileo was, in point of fact, their originator. But Herschel first gave them a prominence which the whole progress of science during the 19th century served to confirm and render more exclusive. Inquisitions begun with the telescope that have extended and made effective in unhoped for directions by the aid of the spectroscope and photographic camera, and a large part of our attention in the present volume will be occupied with the brilliant results thus achieved. The unexpected development of this new physical celestial science is the leading fact in recent astronomical history. It was out of this regular course of events. In the degree which it has actually occurred, it could certainly not have been foreseen. It was a seizing of the prize by a competitor who had hardly been thought qualified to enter their lists. Orthodox astronomers of the old school looked with a certain contempt upon observers who spent their nights in scrutinizing the faces of the moon and planets rather than in timing their transits, or devoted daylight energies not to reductions and computations, but to counting and measuring spots on the sun. They were regarded as irregular practitioners, to be tolerated perhaps, but certainly not encouraged. The advance of astronomy in the 18th century ran in general an even and logical course. The age succeeding Newton's had for its special task to demonstrate the universal validity and trace the complex results of the law of gravitation. The accomplishment of that task occupied just 100 years. It was virtually brought to a close when Laplace explained to the French Academy, November 19, 1787, the cause of the moon's accelerated motion. As a mere machine, the solar system, as far as it was then known, was found to be complete and intelligible in all parts, and in the Mécanique Céleste, its mechanical perfections were displayed under a form of majestic unity, which fitly commemorated the successive triumphs of analytical genius over problems amongst the most arduous ever dealt with by the mind of man. Theory, however, demands a practical test. All its data are derived from observation, and their insecurity becomes less tolerable as it advances nearer to perfection. Observation, on the other hand, is the pitiless critic of theory. It detects weak points, and provokes reforms which may be the beginnings of discovery. Thus theory and observation mutually act and react, each alternately taking the lead in the endless race of improvement. Now while in France, Lagrange and Laplace were bringing the gravitational theory of the solar system to completion, work of a very different kind, yet not less indispensable to the future welfare of astronomy, was being done in England. The Royal Observatory at Greenwich is one of the few useful institutions which date their origin from the reign of Charles II. The leading position which it still occupies in the science of celestial observation was, for near a century and a half after its foundation, an exclusive one. Delambre remarked that, had all other materials of the kind been destroyed, the Greenwich records alone would suffice for the restoration of astronomy. The establishment was indeed absolutely without a rival. Systematic observations of some moons, stars, and planets were during the whole of the 18th century made only at Greenwich. Here materials were accumulated for the secure correction of theory, and here refinements were introduced by which the exquisite accuracy of modern practice in astronomy was eventually attained. The chief promoter of these improvements was James Bradley. Few men have possessed in equal degree with him the power of seeing accurately and reasoning on what they see. He let nothing pass. The slightest inconsistency between what appeared and what was to be expected roused his keenest attention, and he never relaxed his mental grip of a subject until it is yielded to his persistent inquisition. It was to these qualities that he owed his discoveries of the aberration of light and the nutation of the earth's axis. The first was announced in 1729. What is meant by it is that, owing to the circumstances of light not being instantaneously transmitted, the heavenly bodies appear shifted from their true places by an amount depending upon the ratio which the velocity of light bears to the speed of the earth in its orbit. Because light travels with enormous rapidity, the shifting is very slight, and each star returns to its original position at the end of a year. Bradley's second great discovery was finally ascertained in 1748. Nutation is a real-life nodding of the terrestrial axis produced by the dragging of the moon at the terrestrial equatorial protuberance. From its results an apparent displacement of the stars, each of them describing a little ellipse about its true or mean position in a period of nearly 19 years. Now, an acquaintance with the fact and the laws of each of these minute irregularities is vital to the progress of observational astronomy, for without it the places of the heavenly bodies could never be accurately known or compared, so that Bradley, by their detection, at once raised the science to a higher grade of precision. Nor was this the whole of his work. Appointed Astronomer Royal in 1742, he executed during the years 1750 to 1762 a series of observations which formed the real beginning of the exact astronomy. Part of their superiority must, indeed, be attributed to the cooperation of John Bird, who provided Bradley in 1750 with a measuring instrument of till then unequalled excellence. For not only was the art of observing in the 18th century a peculiarly English art, but the means of observing were furnished almost exclusively by British artists. John Doland, the son of a Spitalfields weaver, invented the achromatic lens in 1758, removing thereby the chief obstacle to the development of the powers of refracting telescopes. James Short of Edinburgh was without a rival in the construction of reflectors. The sectors, quadrants, and circles of Graham, Bird, Ramsden, and Carey were inimitable in the continental workmanship. Thus practical and theoretical astronomy advanced on parallel lines in England and France respectively, the improvement of their several tools, the telescope and the quadrant on the one side, and the calculus on the other, keeping pace. The whole future of the science seemed to be theirs. The cessation of interest, through a too speedy attainment of the perfection towards each spurred the other, appeared to be the only danger it held in store for them. When all at once a rival stood by their side, not indeed menacing their progress, but threatening to absorb their popularity. The rise of Herschel was the one conspicuous anomaly in the astronomical history of the 18th century. It proved decisive of the course of events in the 19th. It was unexplained by anything that had gone before, yet all that came after hinged upon it. It gave a new direction to effort. It lent a fresh impulse to thought. It opened a channel for the widespread public interest which was gathering towards astronomical subjects to flow in. Much of this interest was due to the occurrence of events calculated to arrest the attention and excite the wonder of the uninitiated. The predicted return of Halley's comet in 1759 verified, after an unprecedented fashion, the computations of astronomers. It deprived such bodies forever of their portentous character. It ranked them as denizens of the solar system. Again, the transits of Venus in 1761 and 1769 were the first occurrences of the kind since the awakening of science to their consequence. Imposing preparations, journeys to remote and hardly accessible regions, official expeditions, international communications, all for the purpose of observing them to the best advantage, brought their high significance vividly to the public consciousness, a result aided by the facile pen of Lalande in rendering intelligible the means by which these elaborate arrangements were to issue in an accurate knowledge of the sun's distance. Lastly, Herschel's discovery of Uranus, March 13, 1781, had the surprising effect of utter novelty. Since the human race had become acquainted with the company of the planets, no addition had been made to their number. The event thus broke with the immemorable traditions, and seemed to show astronomy as still young and full of unlooked-for possibilities. Further popularity accrued to the science from the sequel of a career so strikingly opened. Herschel's huge telescopes, his detection by their means of 2 Saturnian and as many Uranian moons, his piercing scrutiny of the sun, picturesque theory of its construction, and sagacious indication of the route pursued by it through space, his discovery of stellar revolving systems, his bold soundings of the universe, his grandiose ideas, and the elevated yet simple language in which they were conveyed, formed a combination powerfully effective to those least susceptible of new impressions. Nor was the evoked enthusiasm limited to the British Isles. In Germany, Schröter followed, longo intervallo, in Herschel's track. Von Sachs set on foot from Gotha that general communication of ideas which gives life to a forward movement. Bode wrote much and well for unlearned readers. Lalande, by his popular lectures and treatises, helped to form an audience which Laplace himself did not disdain to address in the Exposition du Système du Monde. The great accession of public interest gave the impulse to the extraordinarily rapid progress of astronomy in the 19th century. Official patronage combined with individual zeal sufficed for the elder branches of the science. A few well-endowed institutions could accumulate the materials needed by a few isolated thinkers for the constructions of theories of wonderful beauty and elaboration, yet precluded by their abstract nature from winning general applause. But the new physical astronomy depends for its prosperity upon the favour of the multitude whom its striking results are well fitted to attract. It is, in a special manner, the science of amateurs. It welcomes the most unpretending cooperation. There is no one, with a true eye and a faithful hand, but can do good work in watching the heavens. And, not unfrequently, prizes of discovery which the most perfect appliances fail to grasp, have fallen to the share of ignorant or ill-provided assiduity. Observers, accordingly, have multiplied. Observatories have been founded in all parts of the world. Associations have been constituted for mutual help and counsel. A formal astronomical congress met in 1789 at Gotha, then under Duke Ernest II, and von Zach, the focus of German astronomy, and instituted the combined search for the planets suspected to revolve undiscovered between the orbs of Mars and Jupiter. The Astronomical Society of London was established in 1820, and the similar German institution in 1863. Both had been highly influential in promoting the interests, local and general, of the science they are devoted to forward, while functions corresponding to theirs have been discharged elsewhere by older or less specially constituted bodies, and new ones of more popular character are springing up on all sides. Modern facilities of communications have helped to impress more deeply upon modern astronomy its associative character. The electric telegraph gives a certain ubiquity which is invaluable to an observer of the skies. With the help of a wire, a battery, and a code of signals, he sees whatever is visible from any portion of our globe, depending, however, upon other eyes than his own, and so entering as a unit into a widespread organisation of intelligence. The press, again, has been a potent agent of cooperation. It has mainly contributed to unite astronomers all over the world into a body animated by the single aim of collecting particulars in their special branch for what Bacon termed a history of nature, eventually to become interpreted according to the sagacious insight of some one among them gifted above his fellows. The first really effective astronomical periodical was the Monatliche Correspondence, started by von Zach in the year 1800. It was followed in 1822 by Astronomische Nachrichten, and later by the Memoirs and Monthly Notes of the Astronomical Society, and by the host of varied publications which now, in every civilized country, communicate the discoveries made by astronomy to divers classes of readers, and so incalculably quicken the current of its onward flow. Public favour brings in its train material resources. It is represented by the individual enterprise, and finds expression in an ample liberality. The first regular observatory in the southern hemisphere was founded at Parramatta by Sir Thomas MacDougall Brisbane in 1821. The Royal Observatory at the Cape of Good Hope was completed in 1829. Similar establishments were set up to work by the East India Company at Madras, Bombay and St Helena during the first third of the 19th century. The organisation of astronomy in the United States of America was due to a strong wave of popular enthusiasm. In 1825, John Quincy Adams vainly urged upon Congress the foundation of a national observatory. But in 1843, the lectures on celestial phenomenon of Ormsby McCate Mitchell stirred an impressionable audience to the pitch of providing him with the means of erecting at Cincinnati the first astronomical establishment worthy of the name in that great country. On the 1st of January 1882, no less than 145 were active within its boundaries. The apparition of the Great Comet of 1843 gave an additional fillip to the movement. To the excitement caused by it, the Harvard College Observatory, called the American Pulkowa, directly owed its origin, and the example was not ineffective elsewhere. The United States Naval Observatory was built in 1844, Lieutenant Maury being its first director. Corporations, universities, municipalities vied with each other in the creation of such institutions. Private subscriptions poured in. Emissaries were sent to Europe to purchase instruments and to procure instruction in their use. In a few years the young republic was, in point of astronomical efficiency, at least on a level with countries where the science had been fostered since the dawn of civilization. A vast widening of the scope of astronomy has accompanied, and in part occasioned, the great extension of its area of cultivation which our age has witnessed. In the last century its purview was a comparatively narrow one. Problems lying beyond the range of the solar system were almost unheeded, because they seemed inscrutable. Herschel first showed the sidereal universe as accessible to investigation, and thereby offered to science new worlds, majestic, manifold, infinitely infinite, to our apprehension in number, variety, and extent, for future conquest. Their gradual appropriation has absorbed, and will long continue to absorb, the powers for which it has served to develop. But this is not the only direction in which astronomy has enlarged, or rather has levelled, its boundaries. The unification of the physical sciences is perhaps the greatest intellectual feat of recent times. The process has included astronomy so that, like Bacon, she may now be said to have taken all knowledge of that kind for her province. In return, she prefers potent aid for its increase. Every comet that approaches the sun is the scene of experiments in the electrical illumination of rarefied matter, performed on a huge scale for our benefit. The sun, stars, and nebulae form so many celestial laboratories where the nature and the mutual relations of the chemical elements may be tried by more stringent tests than sublunary conditions afford. The laws of terrestrial magnetism can be completely investigated only with the aid of concurrent study of the face of the sun. The solar spectrum will perhaps one day, by its recurrent modifications, tell us something of the impending droughts, famines, and cyclones. Astronomy generalizes the results of the other sciences. She exhibits the laws of nature working over a wider area, and under more varied conditions than ordinary experience presents. Ordinary experience, on the other hand, has become indispensable to her progress. She takes in at one view the indefinitely great and the indefinitely little, the mutual revolutions of the stellar multitude during the tracts of time which seem to lengthen out to eternity as the mind attempts to traverse them. She does not admit to be beyond her ken, nor is she indifferent to the constitution of the minutest atom of matter that thrills the ether into light. How she entered upon this vastly expanded inheritance, and how, so far she has dealt with it, is attempted to be set forth within the ensuing chapters. End of Preface and Introduction.